All right, so let's do a quick review of basic features of MATLAB that you'll need to do today's exercise. Well, simple arithmetic. Basic arithmetic operators, same as in Excel. Plus, minus, multiplication is an asterisk. / is division. There's also something called the left division operator, the backslash. It seems really odd, but you can do 5 \3, and that means 3 divided by 5. What that's really used for is solving systems of linear equations, which we will cover on the very last day of class. But until then, you'll probably never use the left division operator. And exponentiation, in other words, raising to a power, is the caret. But don't forget order of operations. Okay, so for example, take this out for a minute. If you want to take the cubed root of something, if you do this, that is not correct. Because remember, the exponentiation has higher precedence than the division. So this is going to take x to the first power and then divide by 3. So that's just going to be x over 3. And x in this case is pi, so that came out to be 1.047. All right, so if you want the cubed root, you have to put it in parentheses. All right, so now it's x to the 1/3 power, which comes out to be 1.46 something. Okay. And by the way, pi is a built-in constant in MATLAB. You can just type pi. And there are also built-in functions, just like in Excel, to do mathematical operations, like trig functions, logs and exponents, square root. And there are also functions for rounding off different ways. And so there's round, which literally rounds off the normal way. But there's also ceil or ceiling, which rounds up, and floor, which always rounds down. And so one problem we used to give, it was one of the ones that was dropped this semester, but calculate how many pizzas you have to order. And if the answer came out to be 2.3, how many pizzas do you order? 3, right? Because you can't order 1/3 of a pizza. And so you use the ceil function to round up. Now remember that just like in Excel, sine, cos, and tan take their argument in radians. But if you have the angle in degrees, there's a different set of functions you can use: sine d, cos d, tan d. And remember, to raise e to a power, which is something you have to do in today's exercise, you don't literally do e caret something, because MATLAB won't understand what e means. You do exp and then parentheses, whatever exponent you want. Okay. Variable names can be up to 63 characters long, but they have to begin with a letter. And the only special character you're allowed to have is an underscore. Okay, you can't have a $sign or exclamation point or anything like that. And of course, no spaces. And remember, they are case sensitive. Right? So if you have these 3 variable names, number in lowercase, number in uppercase, and then number with only the n capitalized, those are 3 different variable names. And that's a pretty common mistake that we see. It usually takes us a while to figure out what's going on, but it's that you weren't consistent with case. So you have number lowercase and number uppercase, and you think they're the same variable, but they're actually 2 different variables. When you have variable names that have multiple words, like average score, it's a good idea to separate them to make it more readable. And there are 2 ways people do that. One is with the underscore. You can't just put a space there, but you can put an underscore. And the other convention that people use is capitalizing all but the first word. Those are just 2 different conventions. Either one is fine. Now, one little pitfall that people often fall into, watch out for this, and it always takes me a few minutes to figure out what's going on when I see this. But don't use the name of a built-in function, like sine, cos, min, max, whatever, as a variable name, because that will then hide the function. You won't be able to use the function anymore. But that's all right. It's easy to recover from that. You just clear the variable. All right, there's a link here on good commenting practices. So you should definitely get in the habit of commenting your code, but don't get carried away. So because we tell you you have to comment your code, sometimes people say, okay, I'll put a comment for every line of code. You don't want to do that. And you also don't want to add a comment that's just redundant with the code itself. Right? Here's a bad comment, add X and Y. That's useless because I can already see that you're adding X and Y just from the code itself. Instead, tell us why you're adding X and Y. What are you trying to accomplish? Like calculate and display the total units of fruit. Okay, I've got different categories of fruit. I want to get the total, so that's why I'm adding them. And good variable names also make your code more readable. Like here, I have no idea what X and Y are. What are they and why would you want to add them? I don't know. Here, oh, I see, I've got different categories of fruit and I want the total units of fruit, right? So I add them. And also when you display output to the command window, instead of just displaying a number, you should always include a message of some kind that says what it is you're printing out. All right, so as far as output on your application assignments. Now for the exercises and grader, it doesn't matter because it's really just for you. All the grader is looking for is that you got the correct answer. But for the application assignments, we want you to follow certain standards. You probably remember that in MATLAB, if you don't put a semicolon at the end, like I did in here, that gets echoed back to the command window, the result of that operation. But if you do put a semicolon, like I did up here, it does not. All right, so the practice we want you to follow, terminate everything with a semicolon. And then you control what goes to the command window. Whoops, why did that happen? You control what goes to the command window, either with fprintf, which is what we had you use in 1181, or there's also disp. And I like to use disp to start out because it's just simpler. Okay? We'll actually cover fprintf in a couple of weeks, and then you can use fprintf. All right, so you can see, now I see the sign of pi is and a number, the cube root of pi is and a number. By the way, notice the number that I got for the sign of pi. And the sign of pi should be 0, right? It didn't come out to be 0. It came out to be 10 to the minus 16 power. That's just a fundamental problem that you'll always have with doing arithmetic in computers. There's a limited precision, a finite precision with which it can represent numbers. So something that should be exactly 0 will never come out to be exactly 0. There'll always be a little bit of round off error. Okay? So you have to watch out for that. Okay, now if you remember how to use fprintf from 1181, that's fine. Okay, we're saying for the first part of the class, you can use disp if you want, because it's simpler. But if you're comfortable with fprintf, you can use that too. Okay, in general, well, I have to be careful how I put this. Right? So are you allowed to use a technique that we didn't teach you in class? The answer is yes, as long as you are doing that technique based on your own knowledge and not just finding some solution on the web somewhere that shows you how to do it. All right? Now, there's at least one exception. Like there's one application assignment where the objective is for you to show that you know how to use certain techniques. Logical indexing basically is what it's about. And for that assignment, you have to do it that way, because if you did it a different way, you wouldn't be demonstrating the skill that we're testing. Okay? But in general, if we don't tell you you have to do it this way, in general, it's flexible. Okay? Okay, so we didn't cover disp in 1181, so just a recap of that. You can either display a literal, in other words, just text, by putting it in quotes, or if you want to display the value of a variable, you put the variable name, not in quotes. Now, if you have a recent version of MATLAB, there's a new capability that they've included. Now you can actually display text and numbers on the same line in DISP. It used to be you had to do it this way, like on two separate lines. Now you can combine it into one string on the single line. But the syntax is finicky here. This has to be double quotes, and the way you join them is with a plus. Okay, so when you do this, it will automatically convert the value of pi to a string and then join it with this string here. Okay, and you'll see the value of pi is 3.416. Now you should always control the number of decimal places that are being displayed. Don't just use the default. Now, we're not going to be sticklers like, oh, we're taking a point off because you had 3 decimal places and it should have only been 2. But exercise some control over it. Don't just use the default. All right, so you can use the round function for that. All right, so this says round pi off to 2 decimal places. All right. But again, this is a recent feature, so if you have an old version of MATLAB, this may not work. So you can go back to doing it this way. Or here's another way you can do it that's a little more cumbersome. You can convert pi to a string yourself using num to string, and then concatenate it here in square brackets. But again, the syntax is finicky. If you do it this way, it has to be single quotes. If you do it this way, it's double quotes. And you'll understand that a little better in a couple of weeks when we talk about character arrays versus strings. Okay. Or again, if you're comfortable with fprintf, you can use that too. But as I mentioned previously, don't just print out a number. Include some kind of message that says what the number is. The final velocity is. And just as a good engineering practice, of course, you should always include the units.